All right, good morning. We're going to start section 2.4 today. Section 2.4 is titled Measures of Variation. And before we do that, I'm going to look at a little example here that I created. I have two data sets here, data set 1 and data set 2. And I've titled this up above here, the problem with mean, the problem with average. So if we take data set 1 equals average, highlight, hold on, parenthesis, and highlight this data set 1. Okay. Find that data set has an average of 5. This data set over here will do the same thing. Data set 2 equals average. Like that data set. We see that both of these data sets both have an average of 5. Now, if we look at this one, 5, 5, 5, 6, 7, 3, 4, 5, 5, 6. We look at this one, 9, 1, 9, 4, 6, 7, 7, 8, 2, 3. These are two very different data sets. And if you needed to see more evidence of that, we can highlight this column A and do a quick histogram with it. And we're not going to do a whole lot of adjusting to it because that's a pretty good representation right there. Done with that. Just want to grab it and drag it over here away. And then we'll come over here to column C, and we will do a quick histogram with that. And again, I'm not going through all the steps to do a histogram. Perfect. Good enough. And boy, look at this data set. And this one has a large concentration of data right in the middle. It slowly decreases from there outward. This one is the exact opposite of that data set. So the problem here is that mean doesn't tell the entire story, particularly if you want to compare one data set to another data set. So we have to start talking about other calculations we can do with data. And the first one we're going to talk about, the whole section is called Measures of Variation. How do data values vary within a data set? So let's take a look here back at the PDF. 2.4, range. The first measure of variation we talk about is very, very simple. It is called range. It is the maximum data entry minus the minimum data entry. So example number 1 talks about these two corporations, Corporation A and Corporation B, and we're going to work on Corporation A because that's what they use in the examples. Corporation A, we want to calculate the range. So the first thing you'd want to do is order your data set. I have set up Corporation A here into a spreadsheet, and we can go ahead and data, sort that range. There we go. Lowest value is 37, highest value is 47. We can calculate the range equals highest value minus the lowest value, and we get 10. And that tells you that how far out your data is spaced, how wide your data set really is. There's an advantage to range. The advantage to range is that it's very easy to calculate. There's a disadvantage to range. And the disadvantage to range is that if we change a single number, let's say there's a single outlier, that this 47 was not a 47. Let's say it was a 70. Our range has jumped from 10 to 33. That is not an accurate picture of this data set because for the most part, from 37 to 45 is a very concentrated amount of data. This one extra high data value, one single outlier, could completely throw off your range and make your information very inaccurate. So range is nice because it's easy. It's not the best measure because it can be thrown off by an outlier very easily. Put that back to the 47 it was. The next measure of variation that we talk about is what we call deviation. Deviation of an entry in a population data set is the difference between the entry and the mean. So we're looking at how different each individual data value is from the mean. So the first thing we're going to need to do here, we're going to need to calculate. I'm going to come down here. I'm actually going to grab these and pull them out of the way down here. And come right in here, and we're going to also calculate the mean. Let's do this. Insert a row above. And we're going to insert, that's good. We're going to come up here, we're going to calculate the mean really quick. Equals average, and we're going to highlight these numbers. We got an average in this data set of 41.5. We want to calculate variation or deviance. We want to calculate how much each one of these data values differs from the mean. So the easy way to do that is type equals your data value minus your mean, 41.5. We get negative 4.5 for the first one. Again, this looks a little different than the chart that's in the book. Go back to the chart that's in the book. When they do this, the reason it looks different than the chart that's in the book is because our data we've put in order. We sorted it. So from there, we could just drag that down and calculate the deviation of every single one of those data values. Now, here's the problem with deviation. If you think about what average is, and how you calculate average, for every value that is 3 above the mean, there should be another value that's 3 below the mean. That's what average is. So if we came down here and we found the sum of all of our deviation, it's 0 every time. Okay? Let's change that to deviation. That's what the textbook calls it. So that's how we calculate deviation. But again, deviation is only a measurement of each individual data value. It doesn't tell us a whole lot about our data set. Our textbook goes next to population variance. I'm not going to talk about population variance first. We will talk about it, but it is a step in the process to finding our next topic, which is population standard deviation. So here's an equation. Population standard deviation is equal to the square root of the sum of x minus the mean squared divided by population size. If we look down to the guidelines box, it's very important for you to go through and pay attention to this. It tells you the steps to do. First, we need to find the population mean. We've done that. We've calculated our population mean. In this case, it was 41.5. Next, it says calculate the deviation for each data entry, the x minus the mean. We've done that. X minus the mean, that was this column, our deviations. We've done that. Our next step in these guidelines is to take that number, that deviation number, and square it. Okay, let's do that. So here I'm going to type in here parentheses x minus mean and square on it. So what do we have to do? Well, we have to take this number here. So we're going to type equals this number squared and enter. And it has squared that number. Look at what I did there to do that. I used the shift 6, which is the little caret, and then 2. So that tells us that it's squared. And we're going to drag and drop that all the way down. So we've taken all those numbers and squared that. Now, one of the reasons we do that is because these numbers here are negatives and positives. And when you add them up, you get 0. But when we square negative numbers, they become positive values. At the end, we're going to take the square root. We're going to undo that squaring step, and it's going to give us a measurement. So after our square, our next step is to find the sum of the squares. So we're going to have to find the sum of that column. Okay, we know how to do that. Come down here to the bottom. We'll type equals the sum. Highlight the numbers above it. It gives us this number, 88.5. That's the sum of all these variations or deviations squared. Our next step is to take that sum that we just found and divide it by our population size. Okay. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we're going to come down here and we're going to call this is actually titled, this would be called our variance. And that's going to be equal to this number divided by the 10 that we just found. And now we want to find standard deviation. Our next step is going to be to let's take back a look at our guidelines. So we found our variance, population variance, when we took our sum and divided it by population size. To find standard deviation, we take the square root of that number. The reason I came back here and I said I want to skip over variance right now is because if we're finding standard deviation, we find variance in the process of doing that. So we go through, we do our find our deviations, square them, find the sum, divide by n, and that result, which we got 8.85, that result is our population variance. When we take the square root of that, which we'll do next, so standard deviation is equal to SQRT. That's how the Google Sheet recognizes square root. Square root of this number here, we get 2.97, and it's given us a huge decimal here, and that's okay. We can change that by just going up here to format the number. We can do whatever we want if we go down all the way to the bottom to custom. We could choose all different variations of the number. We're just going to go to 2 decimal places right now. 2.97. And we go back here to the textbook and see what they calculated. They took the square root and got 2.97. They said approximately 3. They got the same numbers we did. Sum of their values was 88.5. They divided by 10. They rounded that. Took the square root. Got the same answer we did. Okay. Now let's check. I don't know if Google Sheets has a shortcut. Let's try equals standard deviation. It does. So equals STDEV parenthesis, and let's go ahead and highlight this data and see if we get the same answer. Probably will. Very close. Very close. And I will tell you that I think I know the difference between that one. I think what they probably did was calculate a sample standard deviation, not a population standard deviation. As this over here, we did a population. So let's take a quick look here. We just found the population standard deviation. The next example would be how to find sample standard deviation. Now, some symbols change here. We use X bar instead of mu because it's a sample, but that's just a symbolic difference. Okay, our symbol for standard deviation is this kind of looks. A lot of students tell me it looks like a cannon. Somebody said it looked like a snail. It's actually a Greek letter sigma, but it's a lowercase sigma. It's kind of just like a letter O with a little line off the end of it. If that's for population. For sample, we want to use the letter S. But if we look at this equation right here and compare it back to this equation right here, mathematically all the steps are the same. Symbols are different, but the one mathematical difference is that instead of dividing by the sample size, we divide by the sample size minus 1. So if we look at our sheet here, when we divided by 10, if we did that same calculation, we'll call it sample variance, type in equals this number, 88.5, we would want to divide by n minus 1. 10 minus 1 is 9. And hit enter. Gives us a slightly larger number than what we had here. And then our sample standard deviation, we would take the equals square root of that number and hit enter. And now we see that that is the same number as this. So there is a shortcut in Google Sheets to find standard deviation, but it will only find the sample standard deviation. It will not find a population standard deviation. That's okay, because the vast majority of the time, you're utilizing a sample of data and not the entire population of data. So this will work for you as long as you're doing a sample standard deviation. Sometimes a question asks for variance, gives you a data set, asks you to find variance. If you wanted to take a shortcut to variance, you could certainly calculate the standard deviation using this, and then just take this number and square it, right? That's the difference between the variance and the standard deviation, is that square root. If you take the square root, you get standard deviation. If you don't take the square root, you get variance. So if you have this number, you can just square it to go back to the sample variance. So I hope that was helpful. That gets us up through example really 3 and 4. Example number 5 is some information on how to do this in other technology platforms. So it's not a bad thing to look over if you're using a TI calculator or Microsoft Excel. You could take a look there. And example 6, you could take a look at on your own. That is explaining a little bit about what standard deviation means when you look at a data set. So thank you very much.